Hey guys, welcome back. Houston Math Prep here. In this video, we're going to start looking at absolute value inequalities and how that absolute value works with the inequality symbol. So we can essentially have two main types of absolute value inequalities. We can have our absolute value of x is greater than, or could be greater than or equal to, it would work the same way, some value. So just like with absolute value equations, this is going to have us splitting our inequality into two. So this will give us x is greater than a, so dropping the absolute value and keeping the positive, and then x being related to negative a. But because we are working with inequalities, whenever we bring in that negative, we need to flip the direction of the symbol. So our second statement is going to say that x is less than negative a. Okay, so let's look at what that would look like if we graphed that on a number line. So I'm going to graph both of these down here on the same number line. So here's negative a, and here's a. So graphing each one of those inequalities, I'm just going to go ahead and shade what I can see. So if x is greater than a, that means that I would be above a, or to the right of a. And if x is less than negative a, that means I would be shading to the left, or below negative a. Now in this case, because I am working with strictly greater than and strictly less than, I would have open circles here. Okay, and so when we have this greater than, we end up with two disconnected pieces of our number line shaded. So that becomes an or problem. So if we wanted to write this out, we could say x is greater than a, or x is less than negative a. Since the two do not overlap, that's an or. Just remembering and practicing our interval notation. If we wanted to write these in interval notation, because they are disconnected pieces of the number line, they would require two separate intervals. So our first one down here would be from negative infinity up to negative a, and then we would say or from a up to positive infinity. So x values that fall into one piece or the other can be solutions here. Okay, checking out our other type, again, this could be absolute value of x is less than or equal to a, and it would work much the same way. We still want to do the same thing. Once the absolute value is isolated, we want to split this into two separate inequalities. And I'm going to go ahead and do this as less than or equal to. So my first one will remain the same. Absolute value of x is less than or equal to positive a. My second one, when I bring in the negative a, my sign is going to flip directions. So I get x is greater than or equal to negative a. Coming down to my number line and graphing those two on the same number line, I can see that if I graph x is less than or equal to negative a, that would have me, less than or equal to a, that would have me graphing to the left of a. And if I was graphing x is greater than or equal to negative a, that would have me graphing to the right of a. Of negative a. So what we can see is that we have this overlapping section where both pieces are highlighted or are parts of our solution. So what that does is that creates an and scenario. So now we need x to be less than or equal to a, and x is greater than or equal to negative a. Going ahead and adding my solid dots, what that essentially says is it creates a combined inequality, and it says x has to be between negative a and a, which we have seen written as negative a is less than or equal to x, is less than or equal to A. Or using our interval notation, we would be looking at our solution here between negative A and A. Both have solid dots, so that would be brackets on both ends. Negative A to A, inclusive. All right, that's our intro for absolute value inequalities. In the next couple of videos, we'll look at some examples and see how that works in practice. Until then, catch you next time.